Good evening, all of you.
Good evening, sir.
Sir.
Good evening.
Good evening. Good evening.
Sir.
14. Great. So, you guys could spend some time in some calculation. Guys, you can keep yourself muted whenever you have to speak. That time you can just unmute. So maybe you can use space bar. Okay. So when you press space bar, you will be unmuted, and when you leave it, automatically you will be muted. So that is a good way so that it will not disturb others. Okay. So you practiced. Anybody can tell me what was the homework which we gave last time? Sorry?
Thickness of hemisphere.
Thickness of hemisphere. And the second one? One was thickness of hemisphere. And what was the second one? Guys, come on. None of you remember? I gave something to read. What was it? You're supposed to read something. If you don't know what you're supposed to read, then how you'll read? Okay. Okay, so have you calculated thickness for hemisphere? Anybody did that? Guys? Anybody did that calculation?
Yes, sir. Sir, 25.39.
Okay. I'll just open the Excel sheet which we used and I'll share my screen. You guys can see my screen?
Yes, sir.
So we did some calculation for elliptical, tori spherical, you know, and also did external pressure thickness calculation. Okay. So what was the thickness which you got for hemispherical head? Okay, so Ninad is saying he got 32. Anyone else? So Ninad did hemispherical and conical both. So both were 32, Ninad? Okay, let us first focus on hemispherical head thickness calculation. So do you guys want me to do it? Shall we do it together or you can do it?
Together, sir.
Together. Okay. Who was it?
Sir Mohammad Asif.
Okay, Asif. Okay. So you want us to do it together. Okay. Let us do it then. We'll just open code. But why I'm surprised whether you guys could not find time or you could not understand what was the reason for not doing it. Nobody did apart from Ninad.
So I have calculated and minimum thickness is 25.39, but I want to check it.
Okay, so 25.5 you got for hemispherical.
So minimum thickness, yes sir,
For
not design thickness.
okay, anybody else? Hitesh, Keshav, Dakshat.
So am I audible?
Yeah, I can hear you.
Sir, I also found out, sir, but my book is not with me currently. So, but I remember it was something around 26
26.
mm minimum thickness.
Okay, okay, that's great. Let us do it so that we can check. We can do it very fast. That is not a problem. So what we will do, we'll just copy the formula. So I've copied the formula for hemispherical. Okay, hope you guys can able to see it, right? Okay, so now let us find out the different terms. What was the pressure value? Pressure value what you
So
took?
20 bars.
20 bar or 2 MPa, right? So let us take 2 MPa. Then what is L? Now this is tricky. What is L? What is the
We
L
have to
value?
assume
Yes, go ahead. Keshav, or who have already calculated, you can tell me what is the L value which you took. Then we will see, how it is defined and how we should take it. Ninad? So Ninad is saying
by 9.
D plus 2T is what Ninad is saying. So what was the value, Ninad? So diameter of this is quite large. This is 2500 is the diameter, side diameter, into twice the thickness, but you don't have the thickness till now. So whether you will assume, okay, so Ninad is saying you will take 2506 plus twice T. We'll just let us write down the same thing, 2506. Later on we'll try to formulate 2 times T. This is what Ninad is saying. What about others? KS, which is Keshav is saying, okay, audio is not working. So Keshav, you can always type. Okay, does not matter. So Asib is also saying 2506 plus 2T plus 3. Okay, so this is by Ninad and C. What about others? Ninad is saying, okay. Uh, Hitesh, do you remember what you took? Ahmed, Ankur, Rakode. Guys, participate. Then only you will learn. Just by listening, your learning also will be limited. So better you can watch some IPL matches rather than attending. So 2500 plus 2 time by assuming the thickness plus 3 mm corrosion loss. That's what Ahmed is saying. So which is matching with what Asif has said. So I'll just write Asif plus Ahmed. Okay. So I have 3 response till now. Nobody else. Okay. Now let us see how code is defining, and then again I like to discuss. So I want all of you to participate. Just see and give your opinion. I like to hear from the one who have not spoken till now. Okay. So I like this is L. Okay. Now I want Aman. Just read and tell me what you understood with this statement and how you will calculate L value. This is the definition given by code, right? All of you actually can see it. I'll come to you one by one. Aman, anything you want to say? Okay, Ankur, Dakshad, Harshad, Shashank, Tanishk.
Sir, it is given that L is the ground radius, and we can.
Okay, so shall I read further also, or only this statement is enough for me?
No, sir. We have to obtain the from table UG 37 as it is given there.
So I'll have to refer this table to find out the value of L.
Yes, sir.
But if you see here, the value of L for elliptical head, am I calculating L for elliptical head?
No, sir. No, sir. Sorry, sir.
So that
We
means,
are for hemisphere.
yeah, so we don't have to be bothered about the next statement because it is not for hemisphere. Okay, so I have to just refer this much. So now what do we understand with this? Inside spherical or ground radius. What is meant by that? What is
Inter
my inside radius for this sphere? Inside spherical or ground radius? How many radius spherical vessel will have?
only one.
Only one, right? It is very simple sphere. It will have only one radius. And what is that in our case? Yes, we are trying to design shell which was having 2500 diameter. So we can take 2500 as the inside diameter for this spherical shell. So what will be my radius? Just half of
1250.
that,
So
right?
1250.
1250. So now we know that. Shall I take 1250 or this is my radius? I'll just divide by 2. Is that okay? I just
Yes, sir.
Yes, sir.
I don't need to find the corroded radius. See, if this is a ASME formula, that means L is corroded radius, isn't it? Because we have learned that all the formula gave only corroded dimensions. So if it is corroded, then what will be the value?
Plus 2t.
1253.
Sorry,
1253.
1253. So what I'll have to do, I'll have to just add the corrosion loss. Actually, I'm not adding corrosion loss. I'm actually subtracting the corrosion loss by adding. I'm removing the corrosion loss which was provided. This is my inside ground radius. Any problem in that? Any confusion? guys?
No, sir.
Everybody is in line. Ninad, Ahmed, Idris.
Yes, sir.
Yeah, fine. Pretty clear. I'm just finding the radius, okay, and which is corroded. So first of all, I'll divide the normal radius, so 1250, and then finding the corroded dimension by adding the corrosion allowance. Okay. See, guys, by this internship, you may be learning only 5% of the design philosophies. So the intention should be like if I'm giving you a value of 100, you should try to capture all 100, then only you'll be at 5%. If you are capturing only 10% thinking that okay, any I'll this is beyond the syllabus, I'm doing something great which not others are doing, so that is not true. People are doing lot many things, so don't think that people are not reading or not participating on this type. Now you know that internship is a mandatory thing for colleges. So if you don't believe, there are people who are coming to even while studying, they are working parallelly in companies, and learning the skills. So don't think that you are doing something great and only just by listening you'll be able to be ahead from others. That is not going to happen unless you capture everything which I am telling. Okay, not even single thing you should left. Making sense? Are you with me?
Yes, sir.
Okay,
Yes,
and
sir.
if you don't think that
Yes, sir.
something great we are doing or not interested, then please leave. Uh, it's not if you don't, you cannot give 100%, then there's no point in just wasting time of yours. You can do many things in this time. Okay, so let us go ahead. And so the only intention of mine is to, I'm just giving you very minimum value and you should try to capture each and everything. Don't think that okay, this I have not understood, so it's okay. It is not like that. Okay, and these are the very basic thing. So you should not be confused between what is corroded and what is not corroded, what is radius, crown, knuckle. Okay, so P I have, L I have, other values we have already taken. So I can now go with again the same three thicknesses which we were calculating for others. Minimum thickness required, and that will be P into L divided by 2 times S minus 0.2 times P. So what we got? What is the thickness we got?
1.42.
Right? So now what was the thickness we got for a cylindrical shell? See, this was the thickness for longitudinal stresses, which is half of the circumferential stress. So now you see this is matching with the hemispherical thickness. Okay, and whatever we got is half of the circumferential stress. So you know that if you are designing a hemispherical head, your thickness will be roughly half of the thickness of the cylindrical shell. Making sense? Hope you are able to digest that, whatever I just said. Hemispherical head will have the thickness which is half of the cylindrical shell. Okay, while you can see the other heads, tori spherical we got 45, for elliptical we got 24.8. Okay, so now if I ask you one question, okay, this is the shape which is a kind of dish end. Okay, You just consider half of it. So if I increase the depth of it, if I'm increasing the depth, whether my thickness will increase or decrease. Or let us ask in a different manner. Let us make it as a kind of, so that it's not confusing shape for you. Okay, now you can visualize it as a shell and addition. So if this is the shape and if I'm making it flatter, which one will have more thickness, this one or the flatter one? What do you think? If it becomes flatter, means the radius is becoming more and more, the thickness will increase or reduce?
It will increase.
It will
Increase, sir.
increase. Yeah. So that is what is happening in this case. Okay. My hemisphere is having the smallest radius. Okay. So thickness, what we got is only 12.4. Next is 2 is to 1. For 2 is to 1, we got 24.8, which is almost double than hemisphere. Once we move to torus spherical, which is even flatter, we are getting 45.5 as the minimum thickness. So it is further increased. Now if I select a completely flat head at the end, I can do that, right? I can make, instead of selecting a dish end, I can just build a flat head, isn't it? So my thickness will be more compared to dish ends, or it will be less?
Sir, more.
It
More,
should
sir.
be more, sir.
Right, because if it is becoming flatter, it has to be more and more. Okay, we are going to see that. We will be calculating thickness for this flat head also, but before calculating, we know that it will be coming much more, because now you see that what is the radius of this flat head?
It will be infinity.
Infinity.
Yes,
True.
that's correct. So from a finite value to, we are moving to infinite, definitely my thickness is going to increase a lot. Okay, and that will give you a hint that why we are not using vessels like this cylinder, and at the end we are just building flat end. You will rarely see this kind of vessel. You may see at the other end as a flange and bolted connection, which may be possible. And why we do that? When we have something inside which need to be replaced, some internals, like if it has a filter, there are filter elements. Okay, so I very frequently I have to open it and replace the filter, put new filter. That time I don't have any option. Okay, I need to use a flathead, or even in that case I can make a dish end, and at the dish end one end I can have a flange, which will be bolted with the flange which is welded with the shell. That may be possible. Okay, but we'll rarely see that flathead welded with the end. In that case you will have very high thickness. If I want to use a flathead, what I'll do, I'll like to strengthen it by welding lots of stiffeners. We'll come back to that. Yeah, I don't want to complicate it for you. Okay, so up till that it's pretty clear. Hemispherical head calculation. Any doubt to anyone? Now I can definitely calculate the minimum design thickness. For minimum design thickness, what I'll have to do? This thickness plus corrosion allowance, because I need a thickness where that margin is available for corrosion. Now, if this is my minimum design thickness, I need to take a nominal thickness which is higher. Okay, and if it is achieved by forming, there can be thinning. Okay, so I'll take 16 mm. Can I take 16 mm? Guys, can I take 16 mm as normal thickness? So if I take 16 mm, see if this hemisphere you are making from petals. See, normally hemisphere are always made from petals. Okay, uh, because forming this hemisphere head is very difficult because it has very smaller radius. So normally these are in form of petals. So actually you can use 60 mm because petals are fabricated by forming where the thinning will not happen. So you can always take, but try to mention minimum and nominal thickness both, so that the vendor can decide. If he is not sure that he can achieve the minimum thickness which you have given by forming, then he will take larger thickness. That will be his responsibility. Making sense, guys?
Yes.
Yeah.
Yes, sir.
Yeah. Okay. Now let us go to the next. What was the next shape? It is conical. If I have a conical shell or conical end, what I will do with that? Okay, if I have a conical shell, I'll go to code and find the formula for that. These are the conical head or conical section. I'll just copy this formula, paste it here. So once I have a conical shape, you need to know the angle, right? Because cone is always defined by angle. Okay, so you can see that if I'm using this formula, there is a statement given here that half of x angle shall not be greater than 30 degree. Now what is half of x angle, guys?
Sir, half the angle of top of the cone.
Yes, you're right. So see, this is called the apex. So like if my apex is having 60-degree angle, if it is an equilateral triangle, it will have 60-degree angle, and half of it is 30 degree. So 30 degree is my half apex angle. So code is saying that your conical head shall not have half apex angle greater than 30 degree. Means the apex angle should not be more than 60 degree. Okay, if you want to follow this formula which is given here. Okay, if your half apex angle is greater than 30 degree, you can use the next equation which is given in appendix. Okay, so actually if you go to 1-5G, it talks about either providing a tori shape, which is a tori conical. Now I will come back to that, what is tori conical. Okay, so unless it is unless you don't have any other option, you should not try to exceed the half wax angle. Okay, 30 degree you should not try to exceed. So for our case, let us take the 30 degree as the alpha. Okay, so now what will be my cos alpha? What is cos 30 degree?
0.866.
Yeah, so now here I need that value in radian, right? Because you can see that here cos and number, this is not number, this is degree. So what I'll have to do, I'll have to convert into 180 degrees pi,
Pi level.
right? So I'll have to multiply this with pi, okay, then divide by 180. Now we are getting cos alpha, right? So we have the cos alpha value. What are the other things? We have diameter. What is the diameter like? Now this conical shape, you can see will have lots of different diameters, isn't it? I'll just draw it completely so that you are, there is a shell this side. So that largest diameter of the cone is equal to the diameter of the cylinder. Okay. So in that case, what diameter I should, whether I should take a diameter in between or this maximum one. So code should be pretty clear. So let us see if code is defining that. Okay, because if it's code, then it should define completely. So now the required thickness of conical head or conical shell. So now we'll have to see the definition of D to see whether they have written anything. I'll go to diameter. Inside diameter of the head skirt. So I'm not talking about elliptical. I'll read the part for conical. So what it tells, inside diameter of a conical head at a point under consideration. So for the point where I want to calculate the thickness, I'll have to take the diameter at that point. So what should be my point for consideration, guys? See if I
Base.
want, yeah, please go ahead.
The base of the cone.
Base of the
Cone.
cone is there. We have a cone with 30-degree angle. So now which point? Cone will have lots of different points, right? Which will have different diameters.
So at the base.
At the base. So I think who said Ahmad or Harshad?
Daksha.
Daksha. So Daksha is saying I'll take at the base. What about others? What do you think?
Yes, sir. Base से connect करेंगे.
Ahmad is also saying base. What about others? Aman is also saying base.
So we must take at the base.
At the base. Why you are telling me to take at the base? If I take at, let us say this point, at the middle, my diameter will be less, isn't it?
Yes, sir.
And if my diameter is less, my thickness also is going to be less, because diameter and thickness are directly proportional. So why not to take the minimum diameter so that your thickness will be lower? Why
Sir,
you want,
connect नहीं हो पाएगा ना सर ये शेल से फिर
Ahmed?
शेल का जो डायामीटर है वो डिफरेंट हो जाएगा.
मैं ये नहीं कह रहा हूँ कि मैं कोन इतना छोटा बनाऊंगा. मैं बोल रहा हूँ कोन मैं यही रखूंगा, बट थिकनेस आई विल कैलकुलेट एट दिस पॉइंट so that I get a lower thickness. Yes, Keshav is saying if the point of concentration changes, it would mean that the thickness will vary gradually to the apex from the base. So that means my thickness will be maximum required at the maximum diameter. And then the thickness will vary to become lower when I go towards apex, isn't it? Making sense, guys?
Yes, sir.
So yeah, so if I'm calculating thickness at this point, my thickness will be maximum. If I calculate, let us see, my cone has ended till here. Let us see, I have a shape like this. Okay, so at this junction, my thickness will be maximum. At here, my thickness will be minimum. So can I provide a varying thickness to the cone? I don't want to, right? Finally, I'll have to have this much thickness at this end. So I'll have to select the plate accordingly. And if I'm taking the plate at this end, if it is little higher than what is required, so being higher is not a problem, right? I don't need to machine it for the thickness which is higher. Do you agree?
Yes, sir.
Right? I hope you are understanding what I'm trying to say. I'm saying that the thickness
Yes, sir.
I'll take at like in shell, we have two different thickness if I calculate by circumferential stress and when I select for longitudinal. But finally, we have to satisfy the maximum stress which is coming. So we select the thickness based on circumferential stress. Same thing is happening here. I have to satisfy the thickness which is required at this diameter. So finally that thickness will be required. So I'll have to select the plate accordingly. And I don't need to machine the extra thickness which is there at the other end. I don't want to do additional work. Okay, because machining is going to be really costly. And in that process, if I reduce the thickness somewhere, then it's further problematic. So I don't need to do that. Giving extra is not a problem. Now let us find out. So now I know that if this is the cone, I'll have to take the diameter at the maximum point where the diameter is maximum. Okay. So what is the diameter at this point? Is equal to the diameter for the shell, isn't it? Yes, no? So if this is my inside diameter, so can I take this or I'll have to add thickness? Oh, sorry, not thickness, the corrosion allowance.
Add con-
Sir, we should add it.
Add it, right? So because always we have to add it. There is no confusion, right?
Yes, sir.
We have to find the corroded thickness. So because it's diameter now, so it will be twice the corrosion allowance. Earlier it was only radius, so only one corrosion allowance here. Okay, so I have found now corroded diameter. Okay, once I have that corroded diameter, I have other things already available. Okay, and now I can calculate the thickness. I'll just use the same three things. Okay, now I'll multiply P into D divided by 2 times cos alpha, which is this, into gain bracket SE E minus 0.6 times P. Right? So I think Keshav has already calculated 28.7 by Keshav. I'm getting 28.99. So see whether I am doing something wrong or you did. Check that. Okay. So P into D divided by 2 cos alpha multiplied by the bottommost part SC minus 0.6 P.
So 28.99 is correct.
Yeah.
So 28.99 is correct
29.
that you got.
If you want to check by a short method, if you just see this formula very closely, if you want to rewrite it, see d by 2 will become what? D by 2 is
Radius.
Radius.
radius, right? So PR, if you just ignore cos alpha, it's PR divided by SE minus 0.6 P. This is exactly the formula for shell, isn't it? If the thickness what we got for shell, if we just divide by cos alpha, we have the thickness for cone. So it's very easy. So if I just take a thickness of the shell, where we calculated that this is the thickness, right? I don't know whether this is the thickness which we did for or something else we did here. Design thickness, nominal thickness. I think here we have already added 3 mm. Where is the shell thickness?
That was
25.110.
25.11.
Hmm?
25.110.
Yeah,
The
yes,
TC.
which we have calculated. Great. So I'll just divide that conical shell. I'll just use that 25.11 divided by cos alpha, which is here. Bingo, I have the same value, right? So that means just this formula is nothing but it's cylindrical shell thickness divided by cos alpha. Making sense, guys? Now I'll have to just add corrosion allowance to get the design thickness. Then my nominal thickness, it's a cone, so there might be slightly, we need some allowance for forming. Okay, here it's very close to 32, so if you want to take 32 you can take, but you have to mention the minimum thickness. Okay, so if fabricator is not sure, you can just take 34 mm and use that for plate formation. Okay, making sense?
Yes.
Great. So we have now thickness for conical shell, we have for hemispherical. What is next? We also have a tori conical head. Now what is tori conical? Yes, have you seen it?
No.
Tori conical head. Okay, I'll just show you picture of it. See, tori conical means it will be having, and even in this code itself it is shown. You need to go somewhere for, yeah. You see the cone? It is having a radius at the end. Okay, so that we can join it very smoothly. Now, if I join a cone like this, it's a very sharp change, right? Suddenly from conical to cylindrical. Here it's changing at with a radius, so it's a very smooth change. So if one of the end or your both of the end of cone is like this, is having a radius, then it's called tori conical. Right, guys? Making sense?
Yes.
Yes.
Great. So now I have to find out, if I have a tori conical head, then how we will be calculating the thickness. So can you guys do it? Can I give this as a homework? At least you guys also try to put some effort.
Yes, sir.
Yes.
Yes.
It might not be that easy like hemisphere, but you have to believe that you can do it. Then you'll be able to do it. If you think that, okay, anyway we are reading something very something like rocket science and we'll not be able to get it, then you will not be able to get it. So you have to believe in yourself that you can read it and understand. Okay, and try to do it. Okay, you will be able to do it. Just try to go through whatever sections, try to come back. If one day you could not do, try it again another day with a fresh mind. Okay, You guys can share in the group if you have done something and could not understand, so that others also can reply. Okay, by that way, before end of the class, means before the next class, I want it to be calculated and shared in the group. Okay, hope you guys can do it. If still not happen, we'll discuss. Don't worry about that, but try. That is what I want. Okay, so now we have calculated the thickness for a cylindrical shell, for a elliptical head, for a tori head, tori conical head. Tori conical, you have to do it, so you will be doing it. So that also conical head, hemispherical, everything. We have all the possible types of shape. We know how to calculate the thickness due to internal pressure. For Linder, you also know how to calculate for external pressure, isn't it? You remember that or forgot? Guys, you are there? Hello.
Yes.
Yeah. So let us uh, move to that external. Now there is a, it's not writing as external pressure for formed head, but it is writing as convex side, concave and convex. Okay. So if you remember, say if there is a dish end, you know, if I have a dish end, I'll just insert this dish end. I think we have deleted it. So if this is my dish end, okay, what will be this portion called from inside?
Concave.
Concave, right? The opposite side is convex, right? So no doubt about concave and convex. Now, why code is, when there was cylinder, it said very clearly that internal and external pressure. But for dish and it's saying for concave side and convex side. Why it is? The pressure for concave side and calculation of thickness for convex side. Why do you think there are different words getting used for? Why not just to say, calculation of formed head thickness for external pressure, right? Can we say that? Guys, are you there?
Don't know, sir.
Any idea? It's not a rocket science.
For external pressure.
Ninad is saying yes. Acha, you are there. Okay. Yeah, please, anything which is coming. It's very simple, guys. I'm again saying it's not a rocket science that you are reading. It's very simple and logical. Everything can be answered with logic.
Sir, maybe for external pressure.
Sir, as the pressure is like we calculate by the force upon area.
Uh-huh.
So outside area is not flat one. So because of the shape, we are saying that there is will be some effect of the convex shape.
Mm. See, there will be effect of internal external pressure. That is, see the dish end. If the dish end is connected to a shell, okay, this is my dish end and this is a shell. I'll just make it completely so that you This is how a pressure vessel looks like, right? Can I say this is a pressure vessel?
Yes, sir.
Yeah,
Yes, sir.
yeah, right. So if this is a pressure vessel, and if this pressure vessel it's containing some pressure from inside, so for that internal pressure I need to design this descent for concave side or convex side. You have to design
Sir, for internal pressure, it should be from concave side.
concave side, right? If it is attached like that.
Yes, sir.
If there is external pressure, in the same case, I need to design this descent for using which formula or using which clause? UG33, which is for convex side.
Yes, sir.
Am I making sense?
Yes, sir.
Yes, sir. Yes, sir.
Yeah. So I'm just saying if there is internal pressure, I have to design this descent for concave side by using formula which we saw in UG32. Okay, which clearly says formed heads and sections pressure on concave side. Okay, so it does not matter finally it is internal or external, these are just words, right? Finally internal in this case. Now why this word is given? No, because I can make a vessel like this. Let me just make it as a different color.
So we can visualize it.
Visualize it, right? Okay, great. So anyway, I'll just try to give it a different color. Okay, I'll have to if I'm attaching addition like this, I can do that, right? I'm free to do anything. Code is not preventing me to attach addition, or whether I can make a vessel like this or I can make a vessel like this. So now in this case, when there is internal pressure that is acting on
Sir,
Convex area.
convex side.
convex side, right? So even though it is internal pressure, I need to design this descent for clause number 33, which is for thickness
Convex side.
calculation for convex side. Making sense now?
Yes, sir.
Yes,
Yes,
sir.
sir.
That is the reason instead of saying whether internal or external, because you can attach the descent at any type. No, there may be pressure acting on the convex side. You might have made a vessel like this. So in that case, the maximum pressure will be acting on the convex side, and you need to design that for that. Okay. So now coming back to the 33 section again, we'll go back in this section. Okay. Okay. Now I want you guys to read few lines and tell me what does mean. Let me just pick out the lines which I want you to read. Just forget about this, we'll read that. So for elliptical and toruspherical head, the required thickness shall be greater of the following. Okay, so there are two different methodology to calculate the thickness. So whatever thickness we got from A, let us say I got 10 mm, from B I got 12 mm. So I'll have to select greater of these two. So I'll select finally 12 mm. Okay, that is the meaning of this. Now let us read the first method. Okay, now I want you guys to just read this and tell me what you have understood. It is readable, right?
Yes.
Yes, sir.
Just try to read it and tell me what you have understood.
Sir, this says that the design pressure which we consider for the concave side
Correct.
is 1.67 times than the design pressure of the convex side.
Okay, can I say, means, can it say like that? Can it say us to select the, see, design pressure is always input for us, isn't Tanishq?
Yes, sir.
So if it
Next.
is input, code cannot, yeah, I'll come back. I'll come back. I think, um, who wanted to answer? Okay, I'll come back to you. I'm trying to put some thought for Tanishq. Okay, so like if, see, design pressure is always given to us as an input. Okay, what we have to do is to calculate thickness. So code will never tell you what should be the design pressure.
Yes, sir.
Code will not tell you that the convex side design pressure should be 1.67 times. So now just again read it, okay, and try to conclude. Okay, anybody else like to try? Yeah, Keshav, go ahead.
So what code is asking us is that we have to assume the pressure 1.67 times in the formula that we have used previously for the concave side calculation,
Yes,
and assume the efficiency equal to 1 for all the cases.
very good, Keshav, very good. I'm really impressed. So what code is saying simply, when you have to calculate the thickness for convex side, just use the same formula which we just did. Elliptical head we have calculated, right? Just means the last class. So last class we had one procedure where we used some formula, calculated the thickness. The procedure is same. What we have to do is to multiply the design pressure which is there on the convex side with 1.67 times, and that will give you the design pressure for convex side, and use that for calculating by using the same procedure which we did. So now in this case, just tell me the value what will be, Keshav, for the pressure.
Sir, it would be 3.34 MPa.
Is it?
So for convex,
Yeah, for convex side,
so
what?
we have taken pressure equals to 2 MPa for
Mhm.
the concave side. So 1.67 times it 3.34.
Yeah, pretty close, but just try to think a little bit. Just try to think little logical. Try to visualize what you are saying. Then you will get the answer. Just a little more thought, guys. Little bit more. See, we have 2 MPa or 20 bar as internal design pressure, as a design pressure for concave side. Okay, in this case, 1 bar is my design pressure for which I have to qualify for the convex side pressure.
Yes, sir.
So,
The thickness will also becomes
Sir,
1.67 times.
correct.
yes, sir.
So, will it be like that?
So now the design pressure should be 1.67
times
MPa of 1 times 1.
1.6 times 1.
Yes, sir.
Right, very good, Tanish. So, see, it is not talking about the design pressure which is there in convex side. It is talking about the procedure to follow for convex side. But whatever design pressure in this case we have is 1 bar, right? Now 2 MPa is not at all in the picture because that is the pressure on the concave side which we are not bothered. We are designing the convex side, and the pressure which is we are calling as a design pressure is only 1 bar. Okay, now why I told you to think logically, because see, if you have to multiply the internal design pressure into 1.67 times, so all the time this is going to give you higher thickness than the thickness which you got from concave, isn't it?
Yes, sir.
There is no need at all to find the concave side. Then always we will find the convex side and use it, because we know that this will be giving you higher thickness. Okay, and the second hint is that the external pressure which you wanted to qualify, which is acting on the convex side, is not taking part in the calculation. That should not be the case, right? So both will give you some logic, that somewhere you're doing mistake. Okay, so when reading the code, just try to apply some logic. Okay, uh, so
So plus head word is there means it is saying like that if the design pressure is 2, we have to plus it with the multiplication of 0.167 with 1.67 times with the design pressure, means the value should be 2.167.
why 2.167?
So because a plus head word is there for the head with the pressure on concave side, plus head using means we have to add.
No, this is plus heads means this is a static head is talking about.
Okay, sir.
So that static head is completely, see, whatever pressure is there due to static head, that will be added in the pressure. Okay, so I have not told you till now to calculate static head, so that I want to keep it simple. Okay, but you have to remember always that whenever there is liquid, okay, like in this case which we have calculated, if design pressure is given plus some liquid is filled, then you have to find the pressure due to that liquid. You have to calculate the static head, okay, and add that in the design pressure and then do the calculations. So always you have to use that, right? Any confusion in static head, guys?
No,
Any
sir.
no confusion in static head, right? So whenever there is fluid, which is going to be the case always, almost 90% of time there will be some liquid for some height. You have to convert that into pressure by using that static head formula, that is rho gh. Find out the little bit pressure which is there because of that liquid. Why I'm saying little bit? Because roughly 10-meter water column will give you 1 bar pressure. Okay, so your vessel diameter will not be 10 meter, right? It will be 3-4 meter only. See, where that static head become really critical is for columns. Columns are really tall, so like 40-meter height is there. So for 40-meter height, if it is completely filled with liquid, then it will give you almost 4 bar pressure, the density I'm using for water. So that case 4 bar means it will going to give you a significant change. Okay, otherwise it will be very marginal. But when you are a design engineer, you don't have to leave anything. Okay, whatever little bit is there, you have to use that static head, change your design pressure, and then calculate the thickness. Okay, let us come back from where we started. So now you just read it again, it will make more sense. The thickness computed by the procedure. Okay, we read it from here. For elliptical, okay, I'm just avoiding the tori spherical part because that will be different. Right now my focus is for elliptical. So for elliptical, the required thickness shall be the thickness computed by the procedure given in UG 32 for heads with pressure on the concave side using a design pressure 1.6 times the design pressure on the convex side, 1.67 times the design pressure on the convex side. So I have to use the same 32 procedure, but the design pressure will be 1.67 times 1. Clear, guys?
Yes, sir.
Yes, sir.
Great, good. Good discussion, guys. Okay. So now we are we have done with one of the following. Only one method we have seen. What is the second method by which we have to calculate the thickness? That is thickness as computed by the appropriate procedure given in D or E. So now the B part is referring to some other clause. I'll have to go to now D. So now I can see that D or E means D is applicable for elliptical and E is applicable for torus spherical, which is not currently the part of my calculation. I want to calculate for elliptical, so I'll have to refer only D. So what D is saying, okay, see, once you were at convex side, convex side actually external pressure calculation, okay. So you might be thinking that if you remember the procedure which we followed for shell, that there is a geometrical parameter which is very important for external pressure, isn't it? That L by D, D by T ratio, you remember that? Last time we calculated,
Yes,
we
sir.
used the geometrical
Yes,
chart,
sir.
yeah, and we used the geometrical chart to find A, and then with A we found B, and from B we found applicable pressure. So you might be thinking, okay, so similar thing you might be expecting for descent also, right? That geometrical part should be there. Okay, but it was not there in A, but now you see B is related to your geometrical part. Okay. So if you see that the required thickness of an elliptical head having pressure on the convex side, either seamless or but built up construction with butt joint, shall not be less than calculated by the following procedure. What is the procedure now? It is saying assume a value of T, like we did for shell. We have to assume a thickness. We can assume the same thickness which we have already got for internal pressure, right? Because that is minimum what we have to give. So I can assume that thickness and calculate the value of factor A using this equation. Okay, nothing else is there, only RO, which is outside radius. Now what RO you will select? What will be my RO value for this, guys? You like to see how it is defined, right? So if RO for hemispherical, I'm not worried about hemispherical, so I'll read this one. For ellipsoidal head, the equivalent outside spherical radius taken as K naught D naught. Now what is K naught D naught? So K naught is defined as factor, same definition. See, whenever something is coming, definitely it will be defined because it's code, okay? Everything will be defined. So this is a factor depending upon the ratio. This ratio is nothing but major divided by minor. So in our case, 2 is to 1 because we are selecting 2 is to 1 elliptical head. Okay. So if you use this table, you will get the value of K. So I'll just clicking on the table. This is the table which will give my K naught value, and this is the ratio D naught to S. This is major divided by minor. So for my case, it's this one, right? 2 is to 1. So nothing but 2. For that, K naught value is 0.9. Okay. So same point K naught value. Now I have that K naught. I'll multiply that with DO. What is DO? Again, I'll read that outside diameter of the head skirt. So it is the outside diameter for the addition. Okay. So if I multiply that, I'll get my RO value. Once I have that RO value, I can calculate the A factor. Is it clear?
Yes, sir.
Yes, sir.
Yeah, I'm going to give this also for homework, so make sure that you understand everything. Okay,
Okay.
you have to. I have already shared the Excel sheet in the group. I'll again share because we have added something. You guys can just build this up, further for whatever calculation I'm saying. You can just build it up, and then it will be easier for us to cross check. You can discuss in the group, okay, what you got, so that you can verify with others, and finally we will be having same procedure for before the next class. We'll all be on the same page. Okay, so step one is to calculate factor A. What is next? Step 2 is using the value of A, which is you have calculated in step 1. Follow the same procedure given for spherical shell in 28D step through to 6. This is where we normally, young engineers like you will be lost, that again it's referring something. So just be patient. It's nothing much. Like step 1 we have already did. In step 2 it is saying to go in this clause and follow step 2. So we'll just UG 28D and step 2. So 28D means it has to be before. You can also click on that, but I just want to show you, sometimes it becomes really confusing if you have to directly 28 and what it was, B or D, what it was,
D.
Sir
D.
D.
So 28D I'll have to find out. Yes, 28D is talking about spherical shell. So it was also mentioning for spherical shell. So 28D and then step 2 it is saying, because step 1 we have already performed. So it is also giving you the same formula, but finally that RO value will be different, for spherical and elliptical. So I have to start from step 2. So once I have calculated the value A, now enter the applicable material chart. So for our case it is CS what? Anyone can fill in the blanks? What is my
I
applicable?
516 or 716, something like.
So 516 grade 70 is the material. So which chart I need to follow? Do you remember what chart we followed for cylindrical shell?
971 page number.
Sorry?
971 page number.
Page number. Okay, you remember page number. Better remember chart number, no?
CS2, sir.
CS2, right, Ahmed? Right, exactly right. So we have to follow CS2. Okay. So subpart I have to enter in the applicable material chart, which is for finding out the factor B. So with the value we have already got for A, I can find the value of B. Okay. So once I have that value of B, I can calculate the allowable pressure. Making sense?
Yes, sir.
Right? So by following this method, you will get to know that whatever thickness I have assumed, that will be able to take that external pressure or not. Okay. So both of these calculations you have to perform to decide whether that convex side pressure, the thickness which I have selected, is good for the convex side pressure. Making sense?
Yes, sir. Sir, एक्सेल शीट और ये सेक्शन 2 भी शेयर कर दो.
हाँ हाँ, ये एक्सेल शीट I'll share this Excel sheet. Don't worry. Okay. So you have to build further in the same sheet and discuss in the group. Okay, so that everybody is on the same page. Just don't match the values. Try to calculate. Okay. This is not exam or anything for this course. Just whatever you learn is the takeaway finally for whatever time you are spending with me. Okay. So just try to increase the takeaway and that can be done by participating more and doing some homework, bringing the habit of reading the code. That is going to help you a lot. Okay, guys, making sense?
Yes.
Yes.
I'll
Yes, sir.
share this ASM section 2 also, and I'll share this sheet also. Okay, and let us meet again on next Sunday. And I want all of you to finish the calculations. Finally, we started with 50, now we are at 12. So I think at least we will finish with 12. What you guys say? You
Yes, sir.
agree with me, right? After some time, we should also not leave. Okay, so jokes apart, definitely I know you are going to benefit. So, and I also wanted whoever is interested that should do, because people might have different interest. Okay, so let us meet, guys, and try to do. I'm giving very little bit exercise so that even a little bit effort apart from this class will help you a lot. Ahmed, you want to ask something or just
No, sir.
thumbs up? Okay, great. Thank you, Ahmed. Ahmed is very active in LinkedIn and
Thanks, sir.
everything. Yeah, Ahmed, good. So Ahmed is also doing lots of other, courses, right, Ahmed, for SolidWorks and
Yes, sir.
great. It's really good to keep learning, and that is the only thing which will keep you ahead, right? Unless you are trying to move into software side, IT sector, because most of the core sector is now when you do mechanical or civil or chemical, finally getting placed in IT. Okay, so you don't have to do that if you just keep learning about the industry. Okay, guys, I'll close it here. See you guys on Sunday, right?
Yes. Okay,
Yes, sir.
sir.
Sir,
Okay.
Okay, sir.
Yes, Shashank, you want to say
sir,
something?
can I get sir previous sessions recording, sir? I was getting disconnected various times, so I missed few things. Sir.
Okay, okay, I'll share that.
Sir, the same
Thank you,
problem
sir.
is with me,
Okay, Tanish, I'll
sir,
share in the
because
group.
my midsems were there.
Okay, no problem. So what I'll do, I'll share the links for the previous class, okay, and go through that and try to do the exercise which we just now discussed. Okay, better to write it down, the exercise which I have given, so that you don't forget it at least, because after few days you will be able to, you will forget whatever we have discussed. Okay, guys, bye bye. See you.
Bye, sir.
Thank
Bye.
you,
Bye,
sir.
sir.
Thank you,
Thank
sir.
you.
Thank you, sir.
Welcome, guys.
Thank you, sir.
Welcome. Bye bye.